we are asked to find y prime for this function over here. Now this is implicit, right? Because I have the x's and y's on both sides, and I don't have it explicitly solved for y. We don't have something like this. Y equals something with x's in it, right? We don't have that. In fact, let's get rid of that. We don't have that. But we do know that y is an implied function of x. I mean, perhaps we could solve this for y. Sometimes you can, sometimes you can't. We could actually solve this for y, right? We could subtract the x cubed and divide by 3, and then take the fourth root. It'd be a little cumbersome, but we could do it. But right now we know this. Y is some function of x. So I'm just going to write that y is some function of x. So y equals f of x. Y is some, I don't know what this is, but it's some function of x. So now, when I differentiate, instead of writing y to the fourth, I'm going to use the f of x. So here's what it'll look like. 3, and then, how about this? F of x, there's the y to the fourth, plus x cubed equals 10. So all I'm doing is replacing y with some unknown function. Now, all this is in terms of x, so I can differentiate it. Right here, we have a power, so I'm going to use the general power rule, the chain rule. Bring the 4 down as a multiplier, decrease by 1, so we'll get 12, and then f of x cubed, there's a derivative of the outside, times, right, it's a power, so I get the derivative of the outside right here, times the derivative of the inside. Now the inside is f of x. The best I can do is represent it with f prime of x. So here's what we have. Here's the derivative of the outside times the derivative of the inside, and the best I can do with the derivative of the inside is just to indicate it. Now keep going here. So over here we have the plus x cubed, so differentiate that, we'll get plus 3x squared equals, and now 10, differentiate the 10, we'll get a 0. Let's just clean it up. It looks like this. 12, quantity, f of x cubed times f prime of x plus 3x squared, all that's equal to 0. So I'm going to replace those f's with y's. So this is going to be 12 y cubed y prime plus 3x squared equals 0. And I can do that because look back up here. What did we have? All the way back up here. You see it? What was y? Y is our unknown function of x. So just to explain how this worked, I used the f. But now I'm going to go back to the y's. Now I'm trying to solve for y prime. So I'm going to subtract 3x squared and divide by the 12y cubed. Here's what that's going to look like. Up at the top right, we're going to get 12y cubed y prime equals negative 3x squared. Let's divide here. So we'll get y prime is equal to negative 3x squared over 12y cubed. And we can cancel, but that 3 will go into the 12 4 times. So we're going to end up here. Y prime is equal to negative x squared over 4y cubed. Now, I'm going to do this again, but without the replacement with the f. The f was just kind of instructional so you can see where everything came from. But let's just start here. Here's what we have. 3y to the fourth plus x cubed equals 10. So I'm going to use implicit differentiation. So when I do this, I need to realize that that's really a function of x, right? That's really this over here. So I've got a general power. I got the outside, and I got the inside. So when I do this, I'm going to write this. 12y cubed times y prime. Derivative of the outside times the derivative of the inside. Plus 3x squared equals 0. Let's subtract, so we'll get 12y cubed y prime equals negative 3x squared. Divide, we'll get y prime is negative 3x squared over 12y cubed, and then reduce, we'll get negative x squared over 4y cubed.